You want two of me or one of me today? I think we'll just do one of me. All right. I didn't hear. Did somebody figure out what the angle on that triangle would be? We just did a whole bunch of work with reference angles. It's 150. It's 30. Yeah. So we needed the reference angle. I'm going to pop it in here. It's 30. And now we're ready to go. Here's the work. The work, guys, it's quick. To get that x value, you do the hypotenuse 1 times the cosine of 30. So can you do 1 cos 30 for me? And then for the y, we're doing 1 sine 30. Those will give us the two lengths in that triangle. So 1 times cosine 30 is 0.866. And 1 sine 30, 1 times sine 30, 0.5. So what is the point corresponding to 150? It's 0.866 units in the negative direction and 0.5 units up. So careful here, the actual point isn't going to be 0.866. It'll be negative 0.866. And the y value positive 0.5 because we go up. So we had to just be careful with the signs there, thinking about what quadrant we're in. Now you guys humor me. Can you guys do cosine 150, sine 150 for me? They should spit out a value for you. Cosine of 150, negative 0.866. Interesting. Sine of 150, 0.5. Very interesting. We just saw those numbers show up in that point. It appears this might be a pattern. Let's do two more, one in each quadrant. And I think the pattern will become even more apparent to you guys. So let's do it one more time. 225 degrees. Where is 225 degrees? It's in that third quadrant, that bottom left quadrant. And actually, it is 225 is pretty much exactly halfway between 180 and 270. So I'm going to draw it pretty much halfway there. I'm going to draw my angle in standard position there. I'm going to do a teeny tiny little angle like that. So there's 225. And we want to know exactly where that point is. So we'll do the usual. I'm going to drop down and make a right angle triangle. And then I want you guys to find the following. The x, the y, and then put on the 1. So we'd like to use SOHCAHTOA. We'd like to use our shortcuts and find those lengths. But we don't know an angle in this triangle yet. But you guys could find me one. Right? That's the whole point of doing our reference angles. What's the reference angle for 225? Anyone got it yet? It is 45. Yeah, perfect. It's 45 degrees more than 180. So now that we know the reference angle is 45, the rest is pretty quick work here. What are those side lengths? Use our shortcuts. 1 cosine 45. That will tell us that length. X length. 1 sine 45 will give us the y. And then we just got to think about sines, think about where we are on the Cartesian plane for what point that is. So 1 times cosine 45 about 0.707. 1 sine 45 0.707. But think about where we are, guys. That point isn't 0.707 and 0.707. We're in the quadrant where x is negative and y is negative. We're going left that much and down that much. So the actual point would be negative 0.707 and negative 0.707. Can you guys hear me? What's the cosine of 225? What's the sine of 225? Cosine of 225 is negative 0.707. I, for one, am shocked that the pattern has held. Sine 225, interesting. negative 0.707. There's a couple interesting things here, guys. 225 is an angle that can never appear in any triangle. It's more than 180. But its sine ratio exists, but it's negative. That's interesting. All right, guys. Last example to cement the pattern here. 340 degrees. Let's draw it. 340 is pretty close to 360. So I'll draw it over here. Make our right angle like we have been doing. So we zoom around. That's 340 degrees. Make our right angle triangle. And we want to find the x. We want to find the y. The hypotenuse is 1. The hypotenuse is 1. And we'd like to do that using SOHCAHTOA. We need an angle, though. What's the reference angle for 340? I know you guys can use mental math. It's 20. Yeah. Should not. 20. So let's pop that in there. And then it's just light calculator work, guys. Our x, it's 1 cosine 20 in that triangle. And the y is 1 sine 20. And then we'll think about sines. And then this is a new thing I made up. So there's always something to fix. That should be 340. Uh, 0.939. That does round to 0.940 to 3 decimal places. If you wrote 0.939, it's not the end of the world. Sine 20. 0.342. Those are those side lengths. But what point is that? We got to just think carefully. We're in the positive x direction, but in this quadrant, y values are negative. So it'll be negative 0.342 for the y. So 0.940 and then negative 0.342. I wonder what the cosine and sine for these angles are. Cosine 340. Wouldn't you know it? 0.940 and sine of 340, negative 0.342. All right, hopefully you guys are seeing the connection here. It appears that sine and cosine values exist for all these ratios and that they correspond to where we land on the unit circle. The angle 340 ends up at this point, 0.94, negative 0.342. And when you do the cosine and sine, you get those values exactly. There's a correlation there. And to further show you guys this is true, we're going to do this 4 more times, except we don't have to do any work for these points. We're going to find the cosine and sine for 0, 90, 180, and 270. But this is fairly light work for you guys. I'm going to help you out for the first one. 0 degrees is right here. What point is that on the unit circle? Well, you can just see it. It's the point 10. There's no work that's required because we're right on the x-axis. The point for 0 degrees is 10. Can you guys do the cosine and sine of 0? You will get 1 for cosine and 0 for sine. Wow. Amazing. This rule seems to hold. Somebody who hasn't helped out yet today, what point corresponds to 90 degrees on the unit circle? Hassan? Okay. Yeah, that's the point 0, 1. And if you guys try out the cosine of 90, test it for yourself if you don't believe me, you get 0. The sine of 90 degrees is equal to 1. 180 is over here. 180 is the point negative 10. We're we're definitely into the overkill at this point. The cosine of 180, -1. The sine of 180 is 0. And then finally, for 270 degrees, we're down here at 0, -1. Don't take my word for it. Try the cosine of 270. The cosine of 270 is equal to 0. And the sine of 270 is equal to -1. So this is a very cool result, guys. This is kind of the big idea for today. You guys have now seen that every angle has a sine and cosine. And the physical meaning behind those is that they correspond to a pair on the unit circle. So any pair on the unit circle is related to its angle in this way. The point on the unit circle, xy, is just equal to the cosine of the angle and the sine of the angle. The cosine of the angle gives you the x point and the coordinate, and the sine of the angle gives you the y coordinate. Very cool. And we just showed that 8 times with 8 different points. So now we don't even have to do any work for this next one. 134 degrees. Don't draw this. I'm going to erase it in a second. 134 degrees. Where is that? 134 degrees is somewhere over here in this quadrant. Its x is negative, its y is positive. Let's find out what point that corresponds to on the unit circle. We don't need to draw anything out though. You guys know the point is cosine of 134, sine of 134. 3 decimal places is just fine. Do we get a negative x value and a positive y value? Right, 134 is in that upper left quadrant, so the x should be negative. Cosine 134 is negative 0.695 approximately, and the sine of 134 should be positive 0.719. Yeah, the signs check out. You guys do it for 250. Cosine 250, sine 250. Again, don't copy this down, but where's 250? 250 is somewhere down here. So our x should be negative and our y should be negative in this quadrant. Does that work out with 250? Cosine and sine of 250. Cos 250, sine 250. Thanks, guys. Cosine 250, negative 0.342. The sine of 250, also negative 0.940. Exactly like it should be. Because in this quadrant, the x values are negative, the y values are negative. That means the cosine and sine of 250 both negative as well. And finally, 354. You guys know 354 is very close to 360 in that quadrant. So what are we expecting? A positive x and a negative y. Cosine 354, sine 354. Is the cosine of 354 positive? Is the sine of 354 negative? Just double check. Yeah, cosine 354, 0.995 if you round to 3 decimal places. Sine 354, negative 0.105. So every angle corresponds to a point on the unit circle. The cosine is the x and the y is the sine. So let me ask you guys this question. You can think on it for a second. Angles between 90 and 270 always have negative cosine ratios. So why would that be? So angles between, remember, 90 is up here. 270 is down here. So we're talking about angles in these two quadrants here. Always have negative cosine ratios. You think you know why that's true? Think about any point that's in these two quadrants over here. What's true about every point that's over here in this rectangle? All the x values are negative, right? X values are negative in these quadrants. Let me just punch that in here. Can you guys jot that down? Remember, points on the unit circle correspond to the cosine and sine of those angles. The cosine is the x value, like we just talked about. So if you have any angle that finishes over here, since the x value is negative, that's why the cosine values are negative over here and positive over here. And it's the same thing for, in a different way, for angles between 180 and 360. So let's draw a similar diagram on the other side. So 180 is here, 360 is here, and any sine of an angle between those two guys is going to have a negative sine ratio. Why is that? Because any point in these quadrants has a negative value, because we're in those two quadrants. We're going down. The y values are all negative. So a similar point here, y values are negative in these quadrants. So we have a bit of a rule for when sine and cosine values are positive or negative. It depends on what quadrant you're in. For cosine is negative in these quadrants and positive in these. Sine is negative in these quadrants, positive in the ones above. And in about 2 minutes, we're going to have a nice rule that summarizes these things. So that's cosine and that's sine. Well, what about the tangent ratio? So this is the last shortcut we're going to make use of. So tan is opposite over adjacent. And based on all the triangles we've been using today, that means the tangent is the y value over the x value. So guys, think about it. If the y value is positive and the x value is positive, that makes tan positive because you're dividing the same sign, right? Same thing if it's negative over negative. So if the x and y value have the same sign, then the tan of the angle will be positive. So can you guys jot this down? Tan theta is positive. And if the x value and y value have different signs, then tan theta is negative. So we have these rules for when sine, cosine, and tan are positive and negative, but it's hard to remember the rules as we've laid them out. So we have a nice simple rule. This is the culmination of everything you guys have investigated today. Something called the cast rule. A nice, easy visual that everybody can redraw on any quiz or test or anything. It's you draw the 4 quadrants and write down the letters of the word cast, starting in the bottom left and going this way. So what do these letters represent in the cast rule? So in that A quadrant, that first quadrant, remember this is between 0 and 90 degrees. In this quadrant, all 3, and I'm going to capitalize, and I might type it as well. All ratios are positive. Sine, cosine, tan, all the ratios are positive. That's where you guys worked in grade 10. In grade 10, all the right angle triangles, all the triangles work with sine, cosine, it was all angles between 0 and 90. Sine, cosine, tan were all positive all the time. In this bottom right quadrant, where the x values are positive, but the y values are negative, only the cosine ratio is positive. it's kind of a summary of all of our rules. The x values are positive, so the cosine's positive. The y values are negative, so the sine is negative. And because x is positive, y is negative down there, the tangent ratio is negative too. But you can summarize that really succinctly just with only cosine is positive. And the S and T mean similar things for our other two ratios as well. In this quadrant, sine is positive. In this quadrant, tan is positive. Only tan. So up here, only sine is positive. And down here, only tangent is positive. This is the whole culmination of today. You guys saw sine, cosine, and tan. You can have ratios for those for any point on the any point from 0 to 360 and beyond. And we now have a way to predict what their signs are. You guys will never have to predict what the values are, but you will have to predict what the signs are. So as we wrap up, you guys did great today. Here's a simple exercise. Can you guys think about where is 268? Which quadrant is it in? Predict what the signs of the three ratios would be, just the signs, and then verify that on a calculator. So 268. Where is that located? Let's draw it together. Actually, I'll maybe have a sip of coffee while people get that visual down. $268. Roughly speaking, 268 is down here in this bottom left quadrant. Almost at 270, not quite. That's its rough location. So what are the signs of sine, cosine, and tan? Well, think about what quadrant you're in. And if you want to rewrite our letters for the CAST rule there, C-A-S-T, we are in the tan quadrant, which would mean the sine of sine is negative, cosine is negative, but the tangent should be positive. Can you guys check that out? Can you do the sine, cosine, and tan of 268? It's just calculator work. Do you get those same signs? Sine of 268. Negative 0.999. It's negative. Is the cosine of 268 negative? Yes. About negative 0.035 if you round it correctly. If you got negative 0.034, it doesn't matter. And the tangent should be positive. Tangent of 268 is 28. It's big. It's 28.636. But it's positive. We're just reinforcing this CAST rule. That's all we're doing in this exercise. So while I pass around some practice for you guys to do, the practice is light calculator work, basically, just reinforcing this CAST rule idea. Can you guys draw 472? Which quadrant is it in? Predict the signs using the CAST rule, and then just use a calculator and do sine 472, cosine 472, tan 472. If you can, guys, after today, if you can draw an angle, know what its reference angle is, and be able to predict the signs, then you are good to go. You've got everything you needed to from these first 2 days, and you're ready to hit the ground running for our next lesson. So let me pass around the practice, and then I will take that one up with you guys. So remember our talk from Friday. It's worth doing the practice, even if it's not worth marks. And if you need to do a bit outside class to make sure you have things mastered, then that's what you do, just to get better. Bye for you guys. I'll keep her stuff. I appreciate you guys looking over. It's gotta be okay. You guys gotta miss a little class too, so I appreciate it. Yeah. All right, let's take this one up. So where are we? I got to write this out because I'm old. 360 if we're going around, and then 450, and then 540. So 472, did you guys draw it somewhere up here? Okay, so if you label, maybe you don't even need to label the letters. CAST, okay. We're in the quadrant where the X's are negative, the Y's are positive. Only sign is positive here. Does this check out when you do sine, cos, and tan of 472? I got positive 0.927. Cosine, I'm expecting negative. I got a negative 0.375. And I'm expecting my tan to be negative as well. The tangent of 472, negative 0.2475. So guys, one last time, if you can do this exercise, you're all set. Know how to draw an angle, and then we can use this new CAST rule we developed to predict their signs. There's no way you guys can predict the actual values, but I will expect you guys to understand where sine is positive, cosine is positive, tangent is positive, okay? And that's the theme of the practice. The practice, guys, really draw an angle, make a prediction, and do the calculator work. Just there's really not a ton of thinking involved. It's just verifying this new CAST rule, okay? So the lesson was more kind of exploratory in nature. The whole point was to kind of get here with the CAST rule and show where that comes from. So, yeah, good job today, guys. I kind of tried something new, different than I normally do with this stuff. And for the most part, I think it went okay. We'll see how the practice goes for you guys. I got to tidy up and then get some things posted. And then I'll take up a couple from the practice with you guys.